If you have a quadratic formula, you know that any quadratic equation can only have two roots at most, right? Because of minus b plus or minus two roots. But if you don't have the formula, how can you prove that the actual there's only two roots and no more? Right? Even the formula, it may not be complete. It may only give you two. There may be another one somewhere. Right? So somehow we have to show that you can only have two, you cannot have more. And so it's kind of outside the classroom. The classroom show you how to use a quadratic formula. So now you're asking more questions, saying, hey, the formula gives me two. Maybe there are more. And so how can we show that there's only two and no more? And so it's still a little beyond quadratic formula. And so this one here, again, A and B, A and B are integers. And then one of the roots is this guy. Now that doesn't look like the minus b plus the radical b squared minus way to a. So if that's one of the roots, you want to find a plus b. A and b are the coefficient constant. And so the problem is this guy. And that one's very similar. So we have the other one. So let's see if we get. So we'll work out a few problems, and then we have lunch and then we'll go back, you can do it. And so this one here, you want to reduce to the second. Once you get to the second, you know what to do. You have a quadratic formula, right? And so you can try that. The possible roots, because the last number is 4, there must be 1, 2, 4, or the negative of it. And so if you plug in one of the numbers, so you see one work. So x minus 1 is a factor, and so we'll try to prove factor out, be divided, and that's what you get. Well, that one you can use the quadratic formula. And so that was very simple. You just reduce the second degree. Now, this guy here, actually, I should maybe do it anyway. We'll do this and then maybe do the rest. If m is one of the roots, you want to find the other one. You see, that's a trick to it. See, if you say m, if you don't do it this way, if you just go ahead, if you treat it as an exercise and say, well, m is the root, one of the roots, so m will be what? A minus b plus or minus b squared minus 4ac, so it's 4a squared divided by 2a. So if m is one of them, well, the other one is this guy. Right? But they don't want this. They want it in terms of m. So you can see that, in terms of m, it's not that simple anymore. It's rather complicated. And so you have to find a better way to find the other guy. So in this case, we say, well, if we have that, well, if you divide by m squared, well, you're going to get a plus b over 1 over m plus that. So it makes a 1 over m squared, 1 over m is also a root. And so just by simple divide that by m squared, and you get the other guy, which is x squared, ax squared, bx plus a, which is the same as this guy. So 1 over m is also a root. And so you have two roots, m and 1 over m. And so you don't have to deal with the quadratic formula. And so it's a little trick. You should see that they are symmetric. So you can divide it, you get the same thing, switch them up, you get the same thing. So you always look at some of the characteristic of the problem. Same thing this one here. See, it's the big numbers. And so obviously we're not going to use any quadratic formula and that kind of stuff. And so, but we know that a is not equal to 1 over b. So do exactly the same thing. If you see that it's a symmetric, you got 2 here and 3 here, and then 3 here and 2 here. And the middle number of those big but did the same thing. And so you divide it, let's say you divide it by a square. So you can see that if y is the answer, and 1 over y is also also answer because they're symmetric. So 1 over y squared is, 1 over y is the solution for this guy, and y is the solution for that one. And so a and 1 over b is the root of the same equation. And so if you multiply, it should be 3 over 2, so it should be this 2 guy. This is 3 over 2. But anyway, let's try to find a way without using the formula. But if we give you the problem in the homework, usually you will just apply quadratic formula, and you're going to get in trouble. And so let's go back. Now, let's go back to this guy. How should we show it? What's the best way to show that you can only have 2? Even if you have quadratic formula, that's no good because it shows that you have 2, there may be more. So quadratic formula does not prevent the equation have more than 2 solutions. How can you show those 2? Yeah.
Maybe you can like set the 3 roots as like
Okay.
A, B, and C maybe. Set like 3
Oh, you want
roots.
to try it?
No.
No. So what you're saying is that A, B, and C. So wow, well you have this, right?
No, not like that. Like, say that this quadratic equation has A, B, and C all as roots.
Okay, but usually people use A, B, and C over here as the coefficients. So you have to do something else. So say what? M, N?
M, N, O.
So M, N, say P, O is better. So those are the now.
Then I think we can make that equation be A and then x minus m, because m has to be a root of the equation. I'm just
I don't quite understand what you're trying to say. X minus M? If M is one of the roots, what happened?
am squared plus bm plus c.
Right? M must satisfy the equation. Right? Now, if M satisfies the equation, so is N. Right? And so is P. Right? So if you try to solve it, so if you combine this, let's say subtract it. If you subtract it, it will be A m squared minus n squared, and then B m minus n, C cancel out. And so, because m and n are different, they're different. And so you can divide by n minus n, because m, let's say m and n are not the same. So you get m plus n. So we have that. So let's combine this two. Let's say m also not equal to p, right? And so you can do the same thing, combine this two. And you get pretty much the same thing, except you get a n minus plus p. So m and n now is n and p. So you get pretty much the same thing. If you combine this two, and also subtract. And so now if you subtract this two, B and B cancel, and N and N cancel, and you end up with A m minus P equals 0. Yeah, but A cannot be 0, otherwise it's not quadratic. And so,
n minus p.
so m minus p must be 0. So m must be. So they cannot be distinct. And so, you reach a kind of a contradiction. different, one stronger than not different. So you cannot have all three. Two of them must be the same. Again, we're not using a direct formula. So we have that. Okay. Now, this one's going to be hard. So for that, so let me give you the first step. They said that the root minus b plus or minus b squared minus 4ac divided by 2. That's all we have. And that will be one of them. We don't know which one. One of them you can do this. So you have to find A. So you get 5A. So that looks pretty difficult. We don't know which one. What's a good way to do it? It's a very common math competition problem. You see it many times. So this one is very similar. What's the difference between these two guys?
So basically, a squared minus 4b equals 7.
Yeah, this guy here, the radical signs here. But this one here, you have two radical signs. You have one with another radical. So what's a good way to get rid of those radical signs? We have too many radical signs. Yeah, this guy here. First of all, I know you got the right answer, but why you know right away that's not right?
Oh, radical 5 is very good too.
Yeah, this guy here is a 2.236. It's too big. You got a negative number. So what's the answer you got? Negative. Minus? Or plus? Yeah. You're going to have plus. Remember that all the roots, you know, like if you have x squared, you have 4, x is going to plus or minus 2, right? So you always plus or minus. But this one doesn't work. Yeah.
X squared minus 2 root 5x plus 1.
You still talking about this guy, right?
Yeah. Yeah, the equation.
Oh, you mean the long equation?
Yeah.
Yeah, the long
The
equation.
equation with like rational coefficients.
Yeah, it's actually the 9 minus 4 radical 5. That's actually negative 2 plus radical 5.
Yeah.
So in a way, this is also true. Also, but that was no good because you cannot have a radical.
Yeah. But it said like find a rational coefficient equation that had this as its root.
Yeah. So what's the equation now?
X squared minus 2 root 5x plus 1 equals 0.
Okay. So in other you get your A's and B's. But the key is just simply change that you find the minus 3 plus or minus. Now what about this guy? 5 what?
5 minus root 3.
Yeah, 5 minus root 3. So if you don't know this trick, if this is the first time you approach it, you're going to get stuck. Because it's get very complicated with the radical sign. But now that you realize many problems are like that, you can create your own problem now. Right? You're going to get one of those, let's say 5 plus a radical 4, radical 3. And then go ahead and multiply it up and put it here. And people will not, unless they have exposed to this kind of problem before, and they will get stuck. But it's actually a very simple problem once you know the trick. Okay, so we have that. Now, here's some more problems. You see, it looks complicated. I mean, you got the cube roots and all, but you see a kind of pattern, but they're the same. So what would be a good way to do it? Like the first one is actually a simple one. And we use the same technique throughout. So any suggestion? Yeah.
Cube root of x equals t.
Yeah, so if you just make a substitution, right, make a substitution and say, hey, this guy is called a t. And so actually it's got t equal to, can I see? 6. The 6?
T equals to 2 or minus.
Yeah.
X equals 8 or x equals minus 27.
Yeah. See, that one people know what to do. But with the cube roots, the people got kind of scared because of that. So a simple substitution will give you, now you can easily solve that. This is simple quadratic. And so if you do the same thing to the second one, now what do you think the second one?
X minus
You can see that.
minus 8 is t.
What was it?
X equals x squared minus.
X squared minus 8 is t.
Yeah, I actually agree. What do you have? What's a good substitution?
X squared minus 8 is
X squared minus 8.
t.
I don't think so, but x still remains.
Yeah, you want to find something that really simplifies this. So again, you're looking for pattern, right? You're looking for pattern. The pattern over here is that this guy and those, all three of them, what's the common characteristic that's shared by all three?
It,
Sort of, 11 and 2 will give you 13. Right? So you got 11 and 2 will give you 13. Or you can say this one and that one kind of 11. Get by the side, we have to work on the side. Yeah. Or you can say this 2 here has something to do with the 2. So that's the relationship. That's why it has to be 11. The 8 is the same. But this one, that one, and that one, it's kind of connected. You know, you got 13 and you got 13, right? So now you have to do around with this. So what's a good substitution now? So, well, what's a good substitution? If you let y be this, if you let the first one be y. See, it's all about the right kind of substitution. Let's say the first one is y. What's the second one? Yeah, so that'll be what? Y minus 9. And what about the third? So that'll be, oh. See, that's not so good. So that's going to be y. So it doesn't work out so well. You guys look at your things. So what you have now is 1 over y plus 1 over y minus 9x and equal to plus 1 over 2x equals 0. So it's not going to help you that much. Huh? What's it? 24? Oh, this guy here? Oh, 24. No matter, it's not helping you that much. See, this guy here, you can actually solve it. You can actually, using quadratic formula or factor, to solve it. Except this guy, see, you have three choices. You have this, or you can have this, or you can have this, right? You have three choices here. Which one would be a good choice?
I tried the second one.
Why? Why the second one's good?
I tried the second one.
It doesn't work. It's 0. I'll just say that. If you plug it in, what do you get? Hmm? 2? 0? Okay. Well, it makes it. In fact, yeah, if you want, add it up. Add it up. See what you have.
I'm trying to add you more things.
Okay, go ahead. I'll raise my heat here.
You like put together all of this?
That's on the bottom, right?
Yeah, it's on the bottom.
Okay.
When you put all of these fractions together, it's everything.
Oh, okay. Let's see what you have. Okay. Oh, okay. In the wrong order.
Good.
It's okay.
Good.
No.
There we go. So basically,
So he combined them.
yeah, so you combine all of these.
Mm-hmm.
And then this. Can I erase this? Or no?
Yeah.
아니 네 보드만.
This is a eraser.
Oh.
You just find
Sorry, it's just so easy to erase it.
If you have a question, ask him. Don't let him get away.
135 squared. So you put all of these things together, and then divide by 3. And then you factorize. And y equals minus my
So-
y equals minus
Yeah,
5,
but
this is to be 0. So
저
the,
나머지
what, this?
He just multiplied it out.
Yeah.
He just multiplied it out.
Where's 무슨 말에서 유치했어?
He just multiplied it out. Multiply, and you get this. And combine, you get that because equal to 0. And then you get to solve for y in terms of x. And so you get this. But now the question is, what's the next step? Now you got y.
So put it in there. Put it in there.
So put it in here, right? 9x. And what's that, minus 5x? And then you can solve it. You can solve it. So the key for the substitution here is that if you multiply them all together, well, you're going to get x to the 4th. If you put put them together, right? You have to multiply these two, you have to multiply this two, and then you have to multiply this two. You're going to get x to the fourth, which is very complicated. And so the whole idea is to let y equal to something, so that it doesn't make it easier. So we won't have y squared instead of x to the fourth. And so that's the key. Now, this one here, you pretty much do the same thing. See, that one's even more complicated than this guy, right? You get all those radicals and with x squared. And so if you say square both sides to get rid of radical, well, you're going to get a middle term with all the radical. And so that's going to get very complicated. You cannot get rid of those radicals. So you want to do some kind of substitution. Then what would be a good substitution in this case? Again, you look, kind of look for a pattern. Yeah, you kind of want to look for a pattern. Try that out. That one actually much trickier than this one. I can give you a little. I think the other one's better. Rather than having all those radical and the x squared, so you can view that as a u, the first one, and the w, and the v, and the t, right? And if you subtract it over, see, if you work with a single letter rather than x squared and all. Yeah, go ahead. Just a hint.
There's a small problem.
Hmm?
That doesn't give us anything.
What do you mean?
But if you do that equation on this thing, you just get 2x plus 1 equals 2x plus 1.
This one is actually. That's, you want to verify that that's actually true. So you get a u squared. What's a u squared? U squared will be 2x squared minus 5x plus 2, right? And then that v squared. See, again, you want to look at the relationship. You see that the 3 and the 5 differ by 2. The 9 and 7 also differ by 2.
Can it talk to you?
So that's why, you know, if you subtract that thing over, this guy over, with a minus 3x plus 1. So this. And then this guy here, you have that x squared minus 9x plus 7. And then, you got it. And then the other guy is x squared minus 7x plus 6. You see, you're going to get the same thing because the difference is 2 and the difference is 2. And then 7 minus 6, 2 minus 1. So this guy here actually is minus 2x plus 1. And this one is also minus 2x plus 1. See, the reason you pick up the pattern is because you see the 9 itself, and 3 and 5. They related. And then also 7 and 6, and then 1 and 2. So the difference is 1. The difference is also 1. So they simply mix them up. So you're always looking for a pattern to make sure they're comparable. So that's why you have this. So if you have like this guy, and if you have this guy, now this one obviously you have this. And when this two cancels out, because they're the same. So you have this. Why this? Well, this one here basically is u minus v equal to t minus w. So, oh, sorry. This two cancel.
Isn't you supposed to be the root of 2x squared minus 4x plus 2?
Yeah, yeah. Different patterns.
Why is u not the root
Oh, don't ask me, ask me.
Why is u not the root of that? Right, but when we calculated that thing, it was u squared minus v squared